Thank you for joining Pioneer. I'm Chris with Norman Public Library Central, and this is the 16th video in our series on the Swift computer programming language. In our last lesson, we learned how to use the JSON serialization class to create a JSON object and then to decode that dictionary. The dictionary first came in as a string : any, that is, a dictionary whose key is a string type but can give us any other type. And then we looked up the properties in that dictionary, and from properties we extracted our forecast, which is the URL that we could use to fetch our forecast. The challenge that I left you with was to use that URL to fetch the JSON object that is the forecast from the National Weather Service, and to then go through this same process and extract today's forecast. Here's my solution. You can download it at the URL on your screen. I begin by getting the weather response on line 60, and then I decode it using my JSON serialization class on line 61. Finally, on lines 65, 69, and 73, I successively extract a dictionary of any objects, which contains a dictionary of any objects, which contains periods. My periods are not a dictionary, they are an array. It's an array of dictionaries, but on line 73, my periods object is not extracted as a dictionary. It is extracted simply as an array of any data type. Then on line 77, I extract the first element, that is element number 0, from my periods array. That element is a dictionary of string : any's, and that is my forecast. I then, on lines 81 through 87, print out that forecast. As you worked through this example, you saw that it was getting a little bit awkward to process all of this data using the dictionary. When you're using a dictionary like this, we have to constantly cast our items, that is, change their data type, and explicitly tell Swift what they are. Also, our dictionary has optionals in it. That is, if you look up something that's not in the dictionary, you get an optional out. So we always have to use our guard statement to deal with that. Today, I'd like to begin digging into object-oriented programming. We'll develop a class to store our weather forecast information, and we'll see that it's a lot easier to work with in that format. Let's have a look. I've provided you with the file lesson 16 classes1.swift, and we're going to use this a little differently than we've seen in the past. I'm going to copy my function name, Swift in small bytes, and put it in main.swift, just like we've done up to this point. But then, in my right-hand sidebar here, I'll make sure that I'm on the first tab. The first tab is your file inspector, and I'll make sure that I have checked target membership for my lesson 16 classes1.swift file, but that I have unchecked it for every other file in my project except main.swift. So main.swift is in my target, but for example, lesson 15 dictionaries challenge is not in my target, so I'll uncheck that. All right, I'm in lesson 16 classes1.swift, and we're going to begin by writing a class. A class is fundamentally just a collection of pieces of information and then functions that work with those pieces of information. So we'll make a class for our weather period. A class is enclosed in curly braces, just like a function, but unlike a function, it doesn't have any parameters after it. So there's nothing coming after the name of the class, weather period in this case. And we'll begin by telling the class what information it stores, which variables. So we'll create a variable for our short forecast, for example. And that variable is a string. And we'll create a variable for our detailed forecast. That variable is also a string. We'll create a variable for our temperature. That is not a string, that is an integer. And we'll create a variable for our temperature unit, which is a string. If I stop here, we'll see that Swift is complaining that weather period has no initializers. We've told weather period that it's supposed to store 4 pieces of information, but at no point have we actually told weather period what those pieces of information contain. One way of handling this is to create an initializer function. This is a special kind of function that is run when you instantiate your class. That is, when you create something of your class's type. We'll see a little bit more how that works shortly. We will create a function called init. It's a special function. It does not use the keyword func. It just begins with the word init. It is an initializer. It can take parameters just like a normal function. We are going to initialize those pieces of information from our JSON dictionary. So I'll create a local variable called JSON dictionary, and I'll tell Swift that this variable is a string : any. That is, a dictionary from string to any. Inside my function then, I have to initialize each one of these pieces of information. So for example, short forecast is going to be equal to the JSON dictionary element that the National Weather Service gives me called short forecast. Remember that I have to cast this to the correct data type. So we'll cast it to a string. But also remember that this is giving me an optional. And so Swift is warning me that the value of optional type string ? Must be unwrapped. My short forecast variable is not an optional. So I can't just put this optional value in it. I have to handle it somehow. One way that we can handle this optional value is to give it a default value. If short forecast isn't in the dictionary or it can't be made into a string, we'll simply provide a string that Swift can use instead. We do that with our nil coalescing operator, 2 question marks, and then we provide it a default option. In our case, just a string that explains that there wasn't a short forecast for whatever reason. We don't worry about why it happened. We'll just print that out to our user. We can do exactly the same thing with detailed forecast. I'm making extensive use of autocomplete, which is one of the big advantages of using a class. I can't autocomplete these keys for the dictionary because Swift doesn't know that they have to be specific things. But I can autocomplete nearly everything else. Remember that your temperature is not a string, it's an integer, and that means that we can't provide a string as a default value. We can't say no temperature provided because that's a string, not an integer. We have to provide an integer of some kind. So you might choose to just put a really big temperature in here, but I can actually choose to put the biggest possible temperature in here. I can tell the integer data type to give me its maximum possible value. So we'll set our default temperature to some gigantic temperature that can't possibly be reached. Finally, we'll set our temperature unit. And for our default temperature unit, we'll choose kelvins. Now, Swift's error message has gone away because we've initialized all 4 of the variables that we have in our class. Next, I'm going to provide a member function for our class. We'll create a function that prints out our forecast. This happens within the curly braces defining the class, but is otherwise just like a normal function, except that this function has access to those 4 variables. It doesn't need any parameters, and it doesn't return anything. It will just print out our forecast. So that completes the initial version of our weather period class. We've created the class, but we have not instantiated. We have not created any objects of this class's type. Let's do that now. I've given you a simple JSON dictionary here called current weather, and we'll create a period, and that period is now of type weather period. If I type my open parenthesis, I'll see that Swift is providing me assistance. It looks at my initializer and tells me that my initializer takes an object called JSON dictionary, and that thing is a string :any. So if I allow tab complete to fill that in for me, I can say that I'm going to create it from my current weather. Finally, I can say period dot, and that dot gives you access to the members of that class. So for example, each of the variables we created, but also the member function print weather. I'll run my code now. And sure enough, I can see that my weather today is sunny with a relatively warm 300 Kelvin temperature and a very sunny detailed forecast. So you can see that I did not provide you with a temperature unit, so our default of kelvins worked perfectly, and since I did give you the temperature in kelvins, this worked great. Your challenge is to modify this class so that it includes the rest of the data from the National Weather Service's weather report. Good luck.